The Learning Lab. My name is Roman Garcia. I'm a physical therapist. This is our first video in a long series that's soon to follow. I will be describing a concept or an idea that we have developed in the clinic, which is called biomechanical markers. Today, I will be describing or demonstrating what a normal hip joint will look like to the examining physical therapist using the concept of biomechanical markers. So if you allow me, I will bring in my patient, Ms. Brisa. Of course, the patient's going to be laying on their stomach. That's the ideal examination to detect these biomechanical markers. Now, one of the most confusing diagnoses or conditions that a treating therapist can have is try to distinguish where the symptoms is arising from. Is it from the lumbar? Is it from the hip? Now, using this concept of biomechanical markers will facilitate that process to a considerable degree. Now, what I will be demonstrating today is what a normal hip will look under these biomechanical concept ideas. Now, they're very simple to perform. I'm sure that you have seen these before. But basically what I'm showing you is a different way of thinking about them. That is the value of this video, is the thought process behind it. Now, the first thing you want to examine is the range of motion, the rotations. Normal hip joints will demonstrate a certain biomechanical rotatory type of function. So basically what these biomechanical concept allows you to do is to have a working idea of the structure of the hip joint itself. Now, simply the patient is laying on their stomach. First biomechanical markers you look for is external rotation. A normal biomechanical external rotation marker for a healthy hip joint would be what you are seeing right now. As you notice, it's very subtle. The pelvis stays flat against the surface. You can see there is no rotation, there is no rising of this pelvis. Very little, insignificant. This is a normal biomechanical marker for a healthy hip joint. The next biomechanical marker you're looking for is internal rotation. Internal rotation normally is considered to be 45 degrees. Again, in this case, you can see that it's approximately 45 degrees. You do not need goniometric measurements for this. You do not need that device. Most experienced physical therapists have a good idea what a normal range of motion is. In this case, we've got 45 degrees. Again, normal biomechanical markers thus far. Another important biomechanical marker you want to look for is the orientation of the tibia relative to the surface. A normal hip joint, the tibias will always be completely vertical to the surface, to the horizontal surface. Again, in this case, you do both at the same time. You know that you've got a normal axis of rotation because of this biomechanical sign or marker. The tibias are completely vertical to the surface. Again, we've all seen these before. We've all seen these signs before. But I think the thought of it telling you the structure of the hip is something that's relatively new. Again, external rotation. You're always looking at structure. What is the status of the structure? What is the status of the structure? Can I get an idea what the status of the structure is? These biomechanical markers will do exactly that. Tibias completely oriented vertically. Internal rotation, 45 degrees. Again, your hand is always on the pelvis. You're not pushing down. You do not want to restrict the pelvis. The pelvis will tell you the dysfunction in the hips. If you put downward pressure and you try to control this pelvis, you you obstruct the biomechanical information that's being given by these motions. You want to let the function express itself naturally. You cannot do that by applying pressure downward onto the sacrum. Again, pelvis stays down. You got 3 biomechanical markers here. They're all normal. The treating therapist at this point starts thinking in terms of structure, the status, the condition of these hips. If all these biomechanical markers are as what you are seeing right here, right now, if this is what's being exhibited, the evaluating therapist knows that there's a 99.999% chance that the structure of these hips are normal. There is no inflammatory process in these hips. Function always follows structure. These are normally structured hips. Again, do not control that pelvis. The pelvis is what tells you the structure of the hips. I've seen other examinations where they try to control the pelvis. My opinion, that is a mistake. If you do that, you sully the examination. You start inputting an external force. So it's not a natural response. You want natural responses here. You're basically studying nature here at this point. You're not studying a book. You're studying nature here at this point. The nature of these joints are normal. Now, if you allow me, I will show you what a hip with these normal biomechanical markers will look like on an X-ray. I'll demonstrate it here for you now. Now, this is an X-ray of a normal hip. As you can see, the femoral head is completely spherical. It's completely spherical. That is normal spherical contour to the femoral head. There's no collapse here whatsoever. Observe the neck of the femoral, the neck of the femur. It's very smooth. There's no osteophytes. There's no mineralization along the cortex here. The upper neck, the lower neck, very smooth neck contour, very healthy. Observe the joint space width. You got a good size joint space width. There's a lot of cartilage in this hip. This is the left hip. This is the right hip. Observe the acetabulum. You got good femoral head coverage. The acetabulum looks very healthy. No cyst formation. This is the left. If you observe the right, similar patterns. The femoral head, relatively spherical. Femoral neck, contour, there's no mineralization. There is absolutely no osteophyte formation. There's no impingement here whatsoever. The lower femoral neck, again, contour, very smooth. Acetabulum coverage over the femoral head. You got good coverage. Again, this X-ray and this hip correlate. This biomechanical marker that I just showed you, this is how the X-ray will look if we were to do an X-ray on this patient. There's a 99.99% chance. So what the treating therapist, following these biomechanical signs and markers, the treating examination, the therapist will get a good idea of what the structure of that hip is. That's what these biomechanical markers allow the therapist to start thinking in terms of thinking. Now, basically, what I just demonstrated is what a normal hip biomechanical marker would look like. If this patient was to be given an X-ray, the X-ray will look exactly like this. So it oftentimes happens where the physical therapist doesn't have access to X-rays or diagnostic examination. He's basically treating somewhat blind. What these biomechanical markers allow the therapist to do is it gives you a thought process on the condition of the joint, or in this particular case, of the condition of this hip. These biomechanical markers are very sensitive, very specific. Now, the important thing is to always follow these biomechanical markers and what they are telling you. Like I said before, these are signs, these are observations that you've made many times in the clinic. Basically, my objective is to change the thought process on what the significance of what you are seeing in the clinic is changing the thought process of the physical therapist or the examining therapist. It gives you an idea of the structure. Remember, function always follows structure. So by being able to have an idea on the state or the condition of the structure, the treating therapist can develop treatment protocols that are more appropriate to the condition of the joint itself. Now, this is just the first video. We'll be following up with other biomechanical markers on different joints in the human body. Every joint has a particular biomechanical marker. These markers are very sensitive. Today I demonstrated what a normal hip biomechanical marker looks like. Again, I am sure anybody that watches this video that this is nothing that they've never seen before, but I think what's different is the thought process behind it. And that, I think that is what is important. So as we go on in this lecture series, again, I will be demonstrating what different biomechanical markers and how they are representative by either a dysfunctioning joint or a healthy joint. In order to be able to define what a structurally involved joint is, you first need to be able to identify what a healthy joint, its movement patterns are. Again, I hope that when you see this video, it will bring some new thought processes to your clinical minds. My name is Roman Garcia, and this is the Learning Lab. Thank you.